Hello, this video will cover section 3.2 for the class Math 1324, and we're going to get started on example 3. Example 3 has a piecewise function, and then you can see that the breaking point, meaning like where the function divides into left and right, is going to happen at x equals 3. So because of that, the domain is being divided on like what happens on the left side of 3. That will be numbers that are less than or equal to 3. And it will also, that will be our option number 1. And then for our option number 2, we will use numbers that are greater than 3. So in other words, if they're greater than 3, they're going to be on the right side of x equals 3. And if they are less than 3, then they will be on the left side of x equals 3. Yep, are we okay with that? So then you guys can see the graph is already here. However, we're going to graph it. We're going to graph our own by hand, just so that we know how we came across that, okay? So let's go ahead and draw some x, y axis there. And then we're going to divide them by ones. 1, 2, 3, 4, 5. Let's do 5. And then the negative x-axis, -1, -2, -3, -4. And try to make them like about the same width, okay, the intervals. And then up, we're going to have 1, 2, 3, 4, 5. And then down, 1, 2, 3, 4. Okay, that's not very good, but we'll just leave it like that. Now, let's go ahead and start graphing option 1, or like the first piece. Remember, those are called piecewise functions. So for the equation of the first part, the first piece of the function, we have this linear function, x minus 2. And from here, we can tell that because the constant term is a -2, by default, since this is written in y equals mx plus b, which we called slope-intercept form, by default, that constant term, which is the b, will give us the y-intercept. So the y-intercept will have the coordinates -2 for the y, and then what will be for the x? 0, right? By default. Because if it's a point on the y-axis, the x-coordinate must be 0. So let's go ahead and graph that one here. Actually, I'm going to graph it in blue. And it will be a solid point, right? Or included. Now, let's look at the slope. And the slope is the coefficient of the x. Since we don't see a number, we assume it's a +1, correct? So then we can say that the slope is going to be +1, or 1/1, which will mean we're going to move 1 up and 1 to the right. So then we're going to do the following. Using that y-intercept, we're going to move it 1 unit up and 1 to the right. So it will be there. And then we can do it again. 1 unit up and 1 to the right. So we'll be there. One more time, 1 up and 1 to the right. Now, I'm going to stop there because that one is actually x equals 3. And we don't want to go past that, right? Because we only want the numbers that are on the left side of x equals 3 or even equal 3. And that is the reason why, since we have this equal part right here, that is the reason why I'm coloring that circle or filling it in. So I refer to it as included. Like 3 is included in that part of the function, okay? So I'm going to connect the points. Oops. Oh, this is a little hard to delete. Oh no. Okay, there we go. So I'm going to connect them with a line, and then we will have an arrow on that left side, okay? Now, let's go ahead and graph option number 2. Now, the equation for option 2, or the second piece of the function, is going to be f of x equals, or y equals, to -x plus 8. Now here, you know exactly that the y-intercept is going to be 0,8. However, for this function, we are concerned about what's happening on the right side of x equals 3. So because of that, that y-intercept is not really good to us. So what we're going to do instead is take that number where the breaking is happening, right? So we already established is at 3. Now I know for sure that 3 does not belong to option 2. However, for graphing purposes, we're going to substitute it like if it was part of option 2, okay? So let's do that. So I'm going to find f of 3 just to see what happens there. And so it will be -3 plus 8, and that will give me +5. So that point is going to be at 3, 5. However, this one is going to be open circle because x equals 3 is not part of this function, okay? And that's what you see here. You guys see that open circle? So that's how I'm going to graph it here. So at 3, 5, it will be here. Now the slope for that one is a -1. So if we say m is -1, it will be -1/1, which will mean 1 down and 1 to the right. So let's use that point that we graphed, the open circle. And I know it's kind of weird when I say open circle. Imagine like it was a hole. So if it's not colored in, it will be like an open hole. Okay? So then we go 1 down, 1 to the right. 1 down, 1 to the right. And then we can connect those points. And there you have your function. Okay? Now, the difference between the graph of example 3 and example 2 is that for this piecewise, there is a gap, right, between them, right here, gap. And when we graphed, last class, we graphed example 2, and I don't have it here, but we have the final answer. And that one is actually, even though it was divided into 2 pieces, for our first option here, which was less than or equal to 2, we had this part. That was the part that was included because the 2 was included there. We have that equal. And for the second one, that was this line right here. Now, the 2 does not belong to that option, but we still had to substitute it into the function, and we got 2, 3. However, if I ask you on the test, what is f of 2, would you substitute it into both pieces of the function, or which one? Option number 1 or option number 2? Number 1, very good, because, again, it's included. We have this part right here. Oh, that's exactly what I was trying not to do. If I press the eraser, everything goes away. Okay, so yeah, because the 2 is included right there, right? So we have that equal part. Now, what happens if you substituted them both on the exam? Am I going to give you any type of partial credit? No. I'm not going to, not even half, because if you substituted in both parts of the function, that means that you don't even understand what a function is. Because a function can only have one y for each x. Only one. Okay, so now we're going to move on to, and this is being recorded, okay? So, example 4. We have here one of the most famous piecewise functions, and it is the absolute value function. I see it here. Now, when you guys were in, I don't know, elementary, middle school, you learned that there's a number line. Let's put 0 there. We'll put 5 here, -5 here. And so you learn that the distance from 0 to 5 is 5 units, right? Since it is distance, it's positive. And if we calculate the distance from -5 to 0, that is also 5 units, positive, because distance is positive. So then we learned that if we ask what is the absolute value of +5, the answer is +5. And if we ask what is the absolute value, of -5, you know automatically that it is positive, right? That you just take the input and you make it positive. So now, in this class, now in the college level, we look at the absolute value function as a piecewise function. So it is divided into 2 pieces. One, the first piece, or option 1, like I like to call it, it's going to be whatever is greater or equal to 0. So then we want to take the right side of x equals 0. And that will be for the first piece of the function. Now, the second piece of the function, the equation is -x, and that is for numbers that are less than 0, or x value. So we want to take the left side of x equals 0. Now, just remember that 0 can only belong to one option, and that is included in here, because we have that equal part on the inequality symbol. So what we're going to do, well, first let me show you how the graph looks. Okay, I'll put it here. It will look like that, like a V shape. So this would be like f of x is equal to the absolute value of x. Now let's see where those 2 lines come from, okay? So I'm going to graph one at a time. And I want to graph option 1 on the right side, okay? So this will be option 1. And we want for x values that are greater than or equal to 0. So that means we want to stay on the right side of the y-axis. So if the equation is just simply y equals x, what could we assume the y-intercept is? Do we have a constant term with the x? 0, because we don't see a number, right? So it's 0. So then the y-intercept is going to be at 0, 0 at the origin. It tends to be there. Now, what is the slope of this linear function? Going up 1 and 1 to the right. So 1 up, 1 to the right. 1 up, 1 to the right. 1 up, 1 to the right. And so that is what gives us this line. However, this line also goes here. But because we are only concerned with the numbers that are greater than 0, or the right side of that function, on the right side of 0, we only take this part right here. So then what we do is we're going to delete or erase that part. Look at the board. Yep. Now, let's move on to the one in blue. Option number 2. So option number 2 is also a linear function. And now for this one, we want to stay on the left side of x equals 0, because for option 2, the domain is defined as x values that are less than 0. So on the left side of x equals 0. And then again, the y-intercept for this one is going to be the point at the origin, 0, 0. Although it's not included there, but I'm just putting it there as a, to guide me. Okay, then, oops. Okay, so now if I use the slope, that is going to be m equals -1, right? Because you have a coefficient of -1 in front of the x. So -1 over 1. So we can go 1 down and 1 to the right. But what if, will this slope be the same if I keep the numerator positive and the denominator negative? Yes, they are the same, because we have that will be -1 and this one will also be -1, right? If we divide them. So yes, they are the same. So this one seems more convenient to me, because that means that I will go 1 up and 1 to the left from that y-intercept that happens to be at the origin. So we're going to go 1 up, 1 to the left, 1 up, 1 to the left, 1 up, 1 to the left. Now we can connect that line. And of course, we will also have it over here, but you guys know already that we don't need that one, right? Because we're only concerned of what's happening on the left side of this graph. So we're only going to take this part, and then we're going to get rid of this one. Oh, not that one. Okay, now if we put those two together, what we got on the left side of this line and what we got on the right side of the other line, and once we merge them, we end up with this shape for the absolute value. Now, since all of your outputs or y values will be positive, that's why you only see the graph where the y values are positive, which will be quadrants 1 and 2. Okay, remember that could be a test question. This is quadrant 1, this is quadrant 2, quadrant 3, and the last one, 4. Okay? All right, that was just to show you where the graph comes from. Now, for example 5, we're going to answer a question. And for that, we're given the problem in writing, but we're also given a graph, okay? Now, you could see on the graph, although they are connected, we're talking about a piecewise function. And you could see right there that one line is steeper than the other, correct? Which one's steeper, blue or purple? Okay, yes. So now let's go ahead and read the problem. So we're gonna have this. Okay, so the Birmingham Waterworks charges its residential customers with a 5/8-inch water line, a basic service charge of approximately $25 per month. So that is relevant. And right here, the 5/8 inch of the water line is just kind of like a little distraction. That's just talking about the diameter of the water pipe. We don't really need it for the problem, okay? Plus, I don't want you to panic with the fractions. Now we move on to the next case. So that means like even if the customer uses 0 water, they still get charged, right? The basic fee. Now let's see the next sentence. We have the first 1,500 cubic feet, and that we're going to use CCF, okay? That will be the unit that we're using to represent the cubic feet of the water. Will cost about $2 per CCF. So let's see, if I only spend or use 1 CCF, how much am I going to pay? 27, very good. So it will be 25 plus 2, right? What if I use 10 CCFs? How many, without the basic charge, how much will that be for 10 CCFs? At $2 per CCF. $20 and then plus the 25, so we'll go 45, right? So what this is telling me And let's go ahead and get started with, we're going to write the equation of that function. So it's going to be f of x, oops. That's an F. Looks really weird. Okay, f of x equals and we're going to place 0 and then 15, and then we're going to put the x in the middle, and then I want you to put the inequality symbols in this direction. So that reads x greater or equal to 0. The fact that we have equal to 0 means that we're including 0. 0 is part of the domain, right? Because the problem told us even if you use 0 CCFs, you still get charged. And for this condition, it tops off at 15 CCFs. So we already have a basic charge fee of 25, and so that is actually like a y-intercept. And if you look at your graph here, it will be this point right here. If you consume 0 CCFs, $25. Now we said 2 per CCF, so it will be, by the way, X is representing the number of CCFs, so it will be 2 times X. So each CCF, $2. Okay, so let's go ahead and answer the first 2 questions because we have enough for that. What will be the amount of the water bill for a customer who used no water? We already discussed that. Basic charge fee, right? $25. Now, find the water bill for a customer who used all 15, okay? So then we're going to use, obviously, this part of the function for 15 CCFs. We're going to use that equation. So it will tell me y equals, or f of x. We could put f of 15 will be 2 times 15 plus 25. And so that will be 30 plus 25, and that will equal 55. How much would it cost to use 25 CCFs of water? Now let's go back to the problem. Now the next sentence after that stuff that I circle in purple, it says to encourage water conservation, excessive water usage is charged at a higher rate. It cost about $4 per CCF for each CCF above 15. So $4. So let's think about this. If I spend or if I use 30 CCFs, are all 30 going to be charged at $4? No, right? So let's do that example. Okay, so let's do that. So if I use 30 CCFs, we're going to have this situation where the first 15 will be charged at, and we already have that answer, right? It's right here, 25, because it's 2 times 15 plus the basic service fee. So that was $5, correct? Now, if I consume 30 CCFs, how many more CCFs do I need to pay at $4? Okay, and how do you know that? So what kind of operation do you guys do in your head to know it was 15? Subtraction? right? It's just like like you guys, we're so used to it, but yes, you subtract it. So 30 minus 15, you get 15. So those 15 will be charged at $4. So 4 times 15 will give me 60? $60, all right? Now let's go back to this problem here. So if they're asking us, what about 25 CCFs? So for the first 15 is going to be, well, let's put the basic charge fee, so 25. And then for the first 15, it will be 2 times 15. And then for the rest, now what is the remaining now? 10, right? And you're subtracting 25 minus 15, 10. So this will be 4 times 10. So now we have 25 plus 30 plus 40. And that will give us $90. Now this part, the 55, it will be constant if you go past 15. And that is because we already know that the first 15 CCFs will be $30 charge plus the basic service fee, 25, it will always give us 55. So that's what I'm going to use in this equation. Instead of putting a 25, I'm going to put a 55. And of course, that will be if X is greater than 15. Should I include 15 there? No, because 15 already belongs to this one here. So option 1. Okay, now we know that each CCF is going to get charged at $4, but we also know that it's not going to be like all the CCFs, only whatever's minus 15, right? So then we're going to generalize that just like we did 30 minus 15, 25 minus 15. We're going to use X minus 15, like that. So let's say if I ask you, I use 45 CCFs of water. So first you have to go here, 45, correct? So it will be 4 times 45 minus 15 plus 55. Now again, we're doing this part right here because we want to know how many CCFs will be charged at $4. And that will be what? 30? So this will become 4 times 30, and then plus the 55 that include the basic charge fee. That's very light. Let me trace it again. That includes the basic charge fee and the $30 that is in here in this 55. The 25 plus 15 CCFs at $2. I repeat, 30 plus 25, that's how we got this 55 here, okay? And so the last question here, it says, find a rule for the function f of x that gives the amount of the water bill when x CF of water are used. So we already finished with that. This is just an example, okay? The actual answer for, what is that, D, is this here. That will be the function rule, the piecewise function. Do you guys have a question? I know when I'm saying it here, it sounds easy, but you know. Now, would I give you a question